ঠিকই তো আছে স্যার। হ্যালো, ঠিকই
হ্যাঁ
আছে।
ঠিক আছে, ঠিক আছে।
আসছি, খেয়ে দিয়ে আসছি। হ্যাঁ।
হ্যাঁ হ্যাঁ।
হুম।
Professor Colley is joined.
Yes.
Oh, Dr. Basu, now sir can start the program.
Professor Colley has joined or not? Professor Colley is there.
3-4টা মোটরসাইকেল একসঙ্গে দাঁড়িয়ে গেছে।
No, Professor College is not here.
Okay, just once calling him.
সব দুটা দুটা করে আছে। নেমে পড়ে বলছে, বলো ওকে সাথে পিটা, ওকে পিটা, ওকে ধরে মার।
না বাবা এমন সব কথা বলে।
Shubham, I requesting you to mute your call. Shubham, I requesting you to mute your
Join
call.
করুন,
ওকে
join করুন।
Shubham, Goswami.
ওকে ওকে স্যার। ইয়েস।
Professor Colley has joined. So can we start the program now?
Yes, yes, sir. You start the program.
Okay. Very good afternoon to all the participants. Very good afternoon to all the members of the IC cell. Good afternoon, Dr. Kamal. Am I audible to you? Dr. Kamal? Dr. Kamal is muted.
Yeah. Sorry, I was muted. Now it is.
Okay. Okay, now we are going to start the program.
Yeah, sure.
On behalf of the organizing committee of this program of the IIC Cell RCC IIT, all are welcome in this program. In this program with us, Professor Alok Kole, President of IIC Cell RCC IIT, myself, convener of IIC Cell RCC IIT, Dr. Devashish Mondal. Besides that, other members, Professor Abhishek Vasu, NIRF and ERI coordinator, Professor Sijan Bhattacharya, IPR coordinator of the IIC Cell, Professor Budhaditya Vishwas is the innovation activity coordinator of the IIC Cell, Professor Urpita Ghosh, social media coordinator of IIC Cell, Professor Hiranmoy Roy, internship coordinator of IIC Cell. And other student, important student members are also joined in this program, in this event. So we know today we are organizing the National Innovation Day to celebrate the birth anniversary of Honorable late President Dr. APJ Abdul Kalam. So to commemorate the birth anniversary of our late President Dr. APJ Abdul Kalam, Government of India celebrates this day as a National Innovation Day in every year, 15th October. We know that Dr. Kalam was not only a renowned scientist, but also a great human being who always motivated youngsters with his humble teaching and inspiring words. We all know the significant contribution of Dr. APJ Abdul Kalam in nation building. Dr. Kalam's harmless creativity and passion inspire to all of us, each and every person in this world, our heart, mind and soul to fight and reach out our dreams. So before going to start this program, I request our President of IICCL, Professor Alok Kole, to say a few words regarding the importance of this organization of this National Innovation Day. Professor Kole?
Am I audible?
Yes.
Am I audible?
Yes, you are audible.
Yeah. On behalf of IIC Cell, I extend my heartiest welcome to Dr. Kamal, our speaker, chief guest for this celebration program. This celebration program is especially on National Innovation Day. This is as per the guidelines of our IIC Cell MHRD.
You do it because they may ask.
So I welcome all the student members, all the faculty members, and other students and faculties. Right. So with this, I request our expert speakers, Dr. Kamal, to start this program.
Okay. Thank you, Professor Kole. We are very eager to listen from Dr. Rajiv Kamal. I just introduce Dr. Rajiv Kamal. Dr. Rajiv Kamal received his BTech and MTech degree in Electronics and Communication Engineering and VLSI Design from Dr. APJ Abdul Kalam Technical University, Uttar Pradesh, and Guru Govinda Singh Bandapasta University, India in 2006 and 2008 respectively. And he did PhD degree in Electronics Engineering from Technical University of Catalonia, Spain in 2017. Since January 2019, Dr. Rajiv has been in Samsung Semiconductor India Research Division as a senior staff engineer. Dr. Rajiv Kamal focuses on the research of on-chip interconnection infrastructure and system on-chip architecture. His recent research interests include globally asynchronous, locally synchronous system, NVMe controller design, DDR controller design, system on chip, FPGA architecture for the AI and ML. Dr. Rajiv has published several peer-reviewed technical papers in international journals and conferences. He is a member of IEEE served as a reviewer of several international journals. He was a recipient of postgraduate fellowship award from Indian government during MTech, and European scholarship during PhD. So many thanks to Dr. Kamal. On behalf of the organizing committee, I again heartily welcome you in this program. So you present your session. So thank you to all again. Over to Dr. Kamal.
Okay.
Before Rajiv
Uh,
starts, I just want to interrupt that one thing most of our student and faculty members know that Samsung is one of the pioneer in memory design, not only in India, throughout the world. And Rajiv is one of the architects in India, those who are working on memory elements. So today's session not only targeting the advanced VLSI memory design, maybe you are going to listen something that yet to come to market for user. So
Yeah,
that is innovation. What is going on in industry, especially in VLSI industry, that user is not going to use it, but they will know what of the innovation is going on. So today's session is really, I think, will be very appreciable and very interesting. So what you Rajesh? Thank you for interrupting.
okay. Thank you,
Thank you.
Vasu. Thank you, everyone, and to inviting me as a speaker. So, let me start. Before starting, I'm giving you some brief regarding to my work in Samsung Semiconductor. See, I am here for the memory design, and we develop the POC in the sense the proof of concept for the next generation. And we are 12 months ahead in the SSD controller and SSD, and we are 18 months ahead of the world in the DRAM designs. Okay, so today I will focus a little bit about the CXL, okay, Compute Express Link. And first of all, what was the drawback in before that? So we identified the drawback, and we are moving towards the CXL. So first, everybody aware about the PCI, okay? PCI Express, okay? So right now, PCI Express Gen 5 is going on in the market, but it has so many disadvantages. See, what is going to change since AI came into the market and the cloud centers are there, edge computing came into the market, so many data processing are there, data centers are there. So, and a lot of hosts, they want to work at a time at the same time, since you are using Facebook, so many people are using Twitter and other social media is there. So you can imagine how many hosts working at a time. So we need a common memory interface. From there, we can from there we can reduce the latency. We can provide the high bandwidth, and the software stack also we can reduce. So my presentation is very simple, related to the future, what we are doing right now and what will come in the future. So people should aware about that, especially students should aware about that. So let me share my slide. It is I created very simple slide to understand everyone what is available, what is the issue in that, and why we are moving to the CXL. I'm going to share my slides. Okay. Can you host, make me the presenter so I can share this slide? Hello.
Professor Anup Koila, make him presenter. Professor Koila is there?
Yes.
Uh, you make him presenter. Dr.
Okay,
Kamal,
okay,
make him
okay.
presenter.
Okay.
Rajiv, the presenter facility is available.
Let me check. Yeah, correct. I got it. Can you see my slide?
Yes.
Okay, sure. So CXL Compute Express Link. Okay, so let me introduce little bit history. What is the CXL? What was the limitation? Since innovation always comes with the limitations. Limitations in the sense what was the limitation or what was the disadvantage in the previous research? The new research come with like that. Okay, we had some limitation in previous research, so we can go with the new research, and CXL is going to be IEEE standard. Before that, PCI Express we people have to use in your PC and data centers, whatever the servers and everywhere. The PCI system peripheral component interconnect is available where processor want to access the memory, then he can only access the memory through
ব্রাউজারের
the
উপরের দিকে দেখ লক একটা অপশন আছে,
PCI
ওখানে গিয়ে
interface.
মাইক্রোফোন অ্যালাউ করে দে, মানে মাইক্রোফোন বাটনটা অ্যালাউ করে দে, ওটা অ্যালাউ করা নেই এই জন্য শোনা যাচ্ছে না। এরপরে কানেক্ট টু,
Please
নিচের
everyone
দিকে দেখ কানেক্ট টু
mute their, please everyone mute their mic, please. Okay, so PCI have, I'm telling you very basic thing. Suppose we have the end device as the SSD, okay? If you go with little costly laptops, you can see the Samsung SSD, okay? Samsung. We call it laptop in our language, we call it a client, okay? So Samsung create SSD for 3 version. We create for the data centers, we create for the enterprise, and we create for the client with the laptop. So if you go with the Apple laptops or if you go with the little costlier version, you can see the Samsung SSD there, okay? So how SSD interact with the user? How you can see, okay, there are, you have 250 GB or 1 terabyte SSD available in your system. So you can open your configuration, you can say, check 2 things. Okay. See, I'm giving you simple, very command. Okay, you want to transfer some data from one location to another location. If you want to transfer data from one memory space to another memory space, how it actually work? What is the background? So once you initiate the command, that command will go to the processor, and processor initiate the things to the controller. That is called the SSD controller. Our controller will take care all the yeah, input output things, and packet will transfer, and means the data will transfer in the form of packet chunks. That is nothing but a PCI Express. Okay. So earlier it was there, it was everything is going good. But from last 10 years, what was the issue? Issues that social media got so much popular. Even from the Orkut age, I'm telling you, and Facebook and other Twitter and so many other Instagram and so many other things are there. Then data. Data is an important part here. Due to huge data, some concepts also came in form of AI and some in the form of data science. Also, these areas are also become very much popular. Okay, so once see, I'm telling you, AI is not a new concept. AI is a quite old concept. It is first time developed in 1956. But since we don't have the processing speed that time, and we don't have the processing, or we don't have the power of memory, so we were not able to execute the AI algorithms. So people will people were not interested in that time because they can't do anything. Okay. So now from 2005 to 2006, we have the GPU and we have the high-speed CPU, high-speed servers are available. Even that, these things are not able to uh, develop or not able to increase the speed of AI. We have lot of applications in the world, they are developing for the AI, but the speed matters, especially in the dangerous zone in the sense that suppose if you want to use self-driving car, okay, if your processor is not high speed, then accident could be happen, and that is means that could be create a mess across the countries. So that's why the so many company I'm talking about, they come together, they discuss, okay, what is the limitation in the PCI interconnect and how we can remove these limitations. So this is the introduction. This is the very brief history about what is the reason that this innovation is come into the market and how these specifications going to be developed for this interconnection. So you can see here in this diagram, in today's world, what is the today's world? You can see the cloud computing, we have to evolve the way data centers are architected, how data centers are earlier architected, and how we have to move into the new domain. How data center we can develop, that we can provide the faster data processing and faster speed, everything to increase compute capacity and deliver faster data processing. We need to integrate accelerators. That is the new concept, acceleration. Acceleration, I'm telling you, in the last release, what we have developed one project that is called the ELAN. That was a huge SOC. That SOC we have developed for the enterprise. Okay, but since data protection is very important right now, so we have added one module, that is the AE, advanced encryption algorithm module. But with this processor, what the inbuilt processor we had, that algorithm is going to be very much bottleneck. So what is the role of? Then we developed a different module for the acceleration of the data. That is called the accelerator actually. So for the AES, we have developed one accelerator that individually it will not do anything. It will only provide the processing of the specific data. Okay, so these are the requirement for the next gen. These are the requirement are there. We need to integrate accelerator that excel at processing a specific workload. Okay, a specific workload. So suppose I have developed one AI algorithm, and that algorithm is required for the self-driving car, or that is required to ADAS in the sense advanced driving assistance system. So that should be very accurate, and that should be very fast. Okay, we cannot compromise because that is related to human life. Okay, so we need accelerators for that. A simple processor can't process such kind of data very fast. Accelerators are going to be future. I'm talking about AI accelerator mainly here. Okay, so right now this is the scenario that capacity is going to be increased day by day everywhere. That is the data are available. We need to process the data. We need to predict the data. We need higher a higher processing speed. We need a lower latency. We need higher bandwidth. So these things we are looking for, and main disadvantage was in the PCI is that PCI cannot access the device attached memory or device cache. Okay, so see, I'm giving a very simple example how a computer works. Computer, every processor comes with three kind of cache, that is called L1, L2, and L3. L3 is the common for, suppose in your processor there is a 4 core, that 4 cores are communicated to, means suppose every core have their own cache. Okay, in my cache, I'm talking about cache in the sense memory. In my cache, I have updated something, and then I will update into the L3 also, so other core can understand. Okay, what is the updation will happen? The same way, other core will, that is called actually coherency. Other core will update their local cache. So they could be incoherent. Okay, what is going on? They could understand. So these features are not available. These features are not supported by the PCI in multi-host configuration. Okay, it cannot support. So that is the become the very challenging for the future. Okay, so because I already told you in the future there will be always multi-host system. Same, yeah, metro heterogeneous system you can say. Heterogeneous system means FPGA work with ASIC and NIC is there, NOC is there, other processing elements are there, and these all memory elements, these all things have to work together. They can share a common memory space. Okay, so what is the advantage that if there is a common memory space, so they will be not in bottleneck. Okay, this is the bottleneck in the sense that they can't every time they don't need to update their cache, nothing. Everything is updated as a common space. They can want to write anything, they can write it. They want to access something, they can access it. Since in the PCI, these facilities were not available. So you can see here GPU, FPGA, AI, processor, SmartNIC that perform computation on data in motion and computational storage to process data at rest. Okay, these devices already connected over PCI Express, but to better optimize how they work together in heterogeneous system architecture, they need compute express link developed through a consortium of the companies representing all major computer architecture. CXL is an open interconnect and a standard that increases memory capacity and bandwidth and enable lower latency. This is the most important part here. It increases the memory capacity, it increases the bandwidth, and it decreases the latency. It leverages the PCI Express 5G physical layer infrastructure to create a common memory space across the host and all the devices. It means that CXL is developed over a PCI only, but not before 5G. Okay, not before 5G. So if people are fundamentally know that how PCI works, then understanding will be very good for this CXL. So better move to next slide. It is the compute express link. What is the benefit for that? It increases the memory capacity, it increases the bandwidth, and enables lower latencies. Okay, for the any ideal memory, these three things are required for the any ideal memory. Okay, so we can go ahead. So in the PCI, that is cache coherent was not there. Cache coherent means what? I am little bit giving you some fundamental about the cache coherence. See, cache coherency means the device is attached to that PCI interconnect. That we normally call it the endpoint, and the PCI is called the root complex. Okay, so any device that is added to the PCI, that is called the endpoint. And here normally PCI nothing but a bus architecture. Okay, bus architecture, here processors is connected, and this bus architecture, master of this bus architecture is nothing but called it root complex. Any device that is attached to this bus architecture is called the endpoint. Okay, so this root complex that is was not able to update cache of this endpoint, means the device is attached to the bus architecture. This processor and this root complex is not able to update the cache. If cache is not updated,
Rajiv audible?
Some network issue probably.
And you can confirm, can
Rajiv will join within few minutes.
Okay.
एक मिनट ठीक है, मैं एक बार फिर से कनेक्ट कर रहा हूँ ना। ठीक है, ओके ओके। Sorry, actually net got disconnected abruptly. Can anyone can confirm me they can hear me or not?
Yes, yes. Now audible clearly.
Okay, okay. So I was in between. First, we need to understand the very fundamental in the sense how PCI work. So there is a root complex and any device that is connected to bus architecture of the PCI, that is called the endpoint, and the PCI root complex is not able to update or not able to create a coherency between device cache and root complex. Okay, so that was the disadvantage in the sense when device want to transfer some data to the root complex, first he create the coherency. Okay, so he want to create the coherency that will take time. If that will take time, that data transfer will go slow. So in the CXL, that is this problem is resolved. So that's why it is the first line it is mentioned. CXL is a cache coherent standard which ensures that the host processor and CXL devices see the same data when they need to access it. That is most important part. In the sense, the device attached, that is the device that is attached to the CXL, they can see the same data, and host processor also see the same data in the sense that they both are updated to the same data, and both the devices, processor and device, will know that okay, what is the data is there and how they can go ahead. So that reduces your initial latency of the system. Okay, the CPU host is primarily responsible for the coherence management. Any device is connected to a host via CXL, then host will take care how to develop the coherency between device and the host or processor, cache memory. Okay, allowing for both the CPU and device to share resources for higher performance and decrease software stack complexity. That is the important. This leads to reduced device cost, of course, and the overhead. What is the overhead? In the PCI, they were not able to do that. That overhead were required that time, and they required more cycle. So first to update themselves. So that overhead is reduced here. Overhead traditionally associated with coherency across an IO link. Okay, the CXL 1.1 specification define 3 new protocols that is called CXI. That is, I will show you in the next slide. The primary protocol is nothing but a little modified PCI protocol only. But CXL contain 3 protocols. They run through the multiplexing on the application layer. Okay. So it will decrease the complexity and higher increase the performance. Now come to the next slide. It CXL 1.1 specification is already available in the market. Market in the sense it is the open, anybody can download. You can simply Google it. CXL is there. Anybody can download. All the world, I'm talking about especially memory designer. Right now they are creating chip that is related to CXL protocol. In my company also, I'm involved in 3 projects or 1 POC. POC, I'm involved with the CXL DDR. Okay, DDR system, we are developing one proof of concept, how DDR will play with the CXL. And that is the second 3 project I am doing right now. I'm involved actually. I am not only, there is a huge team. We are involving on CXL SSD. The coming 3-4 years, these products will come into the market. I think it will take more than that because still we are in the development process, innovation process, and it will take time. Okay. So it has 3 protocols. First one is the CXL.io. That is nothing but a PCI only. It used for the initialization, link up, device discovery, enumeration, and register access. This is used for the, suppose some device is attached to the CXL. First, the host will start the communicated with device via CXL.io. CXL.io will, what it will do? It will first develop the initialize the link up, means it will, some ACK-NACK protocol is there. Through that, the link up will create with the device. Then it will find, okay, which device you are. That is called the device discovery. Enumeration means what are the registered files available in the device. It will enumerate, it will give some number. Okay, you are such device, what is your number? And register access means all the software people use registers only in the device to configure that. Okay. CXL.cache protocol define interaction between the host and device, allowing attached CXL device to efficiently cache host memory with extremely low latency using a request and response approach. Okay, means through that, in the very simple language, CXL.cache, what it can do, it facilitate you to develop the coherency between host cache and device cache. Okay, and third one is the CXL.mem protocol provide a host processor with access to device attached memory. It means if some memory is attached to a device that is connected to the CXL, connected to the device, the CXL protocol can easily access those memory. Earlier in the PCI, that was not there. In the sense, broadly I can say, in the PCI interconnect architecture, CXL.cache and CXL.mem was not there. Right now, CXL.io is nothing but the PCI, but minimum 5 Gen 5. Now we have one more protocol that is called CXL.cache for the cache coherence, a CXL.mem for the memory coherence with a device attached memory. And a different combination of these protocols result in 3 initial CXL usage model. Okay, this is the type 1. Okay. Type 1 device coherently access host memory. You can check. This is the host cache. Okay. Here host can easily access this cache and device cache can easily the host. Okay. This would be, for an example, an accelerator with coherent cache which want to share access to host memory. Usage for type 1 device include PAG, NIC and NIC atomics. These are under process. Companies are developing these type 1 devices. Okay. What is the type 2? It is too much popular. Type 2. Type 2 devices are able to coherently access the host memory, allow the host to access the device memory C. Here I am giving you very inside concept that is very important. Okay. Do you know you know that no the host? What is the host main memory? That is nothing but the DRAMs. Anything if you want to write, read anything if you want. Apart from cache size is very low. Okay. So host write into the DRAM only. Okay. See, suppose user is sitting here. Okay. This is the device memory. Okay. For the PCI, this user can't see this device memory. But a CXL facility, you can see the device memory. Okay. What it mean by that? It mean by that user will only understand this memory is nothing but the part of DRAM. Means here some main memory is there. It is a part of DRAM main memory. Okay. See, here I am introducing one more concept that is called the memory persistence. What is memory persistence? First of all, what is the DRAM? DRAM is a non-volatile memory. If power will go, all the data will go. Okay. So this memory is this is the this is non-volatile memory. Okay, this is non-volatile memory, and user can see okay they have 12 GB of RAM, and he don't know no this is the device attached memory. He only know that this is the memory of DRAM only. Okay, suppose it is the 8 GB extra memory. Okay, so user will understand oh this host have 20 GB memory. Even he will also understand oh 20 GB memory, 12 GB is a volatile and 8 GB non-volatile. So persistence means what? The memory which cannot be deleted after the power gone. Okay, so that is provide you the persistence. That's why the persistence also came into this concept. Now, how a speed will increase, right? Because DRAM is very fast, right? If it is a PC, I know it cannot access this memory. So for user perspective, if you want to increase, but he cannot increase the DRAM, but he can increase the device memory. So virtually he can increase the RAM only, right? Here. Because 12 GB RAM and 8 GB, that for the user it is a 20 GB. User have no access. User will not understand what is this memory, what is that memory. For him, both the memories are same only because he can directly read write here in memory via this is CXL.mem protocol. He can read write directly without any latency, without any overhead. Okay, so that is the beauty of CXL. Okay. So type 2 devices are able to coherently access host memory and allow the host to access device memory. For example, this would be an accelerator with attached memory and optional coherent cache. Using for type 2 devices include GPU and dense computation. This is the type 3. Type 3, increased memory bandwidth and capacity expansion. Persistence memory, already I have explained these things. Persistence memory, how it can provide you the persistence. Here is simply added a memory buffer. This memory buffer, this one and this one. For the user, it behave, okay, both are the DRAMs only here. That is sitting here. He has no visibility to from where these memories are coming. So that becomes the very first, and you can increase the memory capacity without increasing the DRAM capacity, simply because DRAM is quite very costly also. So we can maintain some, that could be some cost effective also. And finally, type 3 devices allow a host to access and manage attached device memory. This could be memory buffer or expander that allows the host expanded across to additional memory. User for type 3 include increased memory bandwidth and capacity expansion as well as persistence memory. This is the official link. If you want to learn, you will get lot of data. What I have given to you, this is nothing but the very fundamental related to the future. And the future, I will expect a minimum it will take 3 to 4 years or 5 years to actual product come on this technology. So thank you everyone for patiently listen to me. And if you have any query, you can ask. I would be like to very happy.
So students and faculty member requesting if you have any query, so you can go for that, please.
Sir, it's an excellent talk. So I am Srijan Bhattacharya. Sir, I am
Okay.
having one question that Samsung is doing this kind of processors and all. So then why this Apple product is getting the more higher price? There is any other reason, or because the Samsung is having very good processor, very fast processor, and very good cameras, everything is there, but still the Apple is getting the higher price. They're charging the higher
Apple, you were
price.
talking about Apple phones, right?
Apple laptops and
We are again going into the market in Samsung laptop also. See, the cost always depend upon the quality, first of all, quality. Second thing, they depend upon the what inside that. If you go with the Apple laptop, you will find all the SSD what they are using. That is nothing but the Samsung SSD only, because Samsung SSD is the most costly SSD available in the market. Okay, the Apple choose everything that is best available, but our market strategy is different. Okay, we are targeting from lower level and middle class people to the higher level. If you see the data, I'm talking about last 2 years. What is the higher phone capacity also? Samsung now ahead of Apple with 34%. Okay, and I'm talking about costly phone. I'm not talking about mass, because Apple provide like iPhone 13 or iPhone 14. You can check those data on the LinkedIn also. We are ahead of 34%. So since what I'm trying to say that the marketing strategy in the sense what class of customer we are targeting. Okay, so normally Samsung targeting each class of customer. We have we have costliest phone in the market. We have costliest TV in the market, but we have TV for 20,000 also, but we have TV for 10 lakhs also. We have the phone for 5,000 also, but we have phone for more than 2 lakhs also. That target market, we want to capture all the market. Okay. So, suppose if you want to compare, no, so I can tell you some phones in the Samsung that is more costlier than Apple phones. Okay. So such a way we can't say. Even you can see we are the number one manufacturer for the SSD, and we have 38% or more than 35 to 38% world market capture, and the DRAM in the 48%, 48 above from 48%. But in the Samsung laptop, we are not using Samsung SSD.
yes.
Got it? Na? That is the marketing strategy. We can't do anything.
But technology wise, you can say that it is the higher technology the Samsung is using right now in this electronic field.
At the end product, like especially for the mobile phones, and we have our own processor. We are not dependent on any other body, and we are our own memory for the. We create the SSD for the mobile phones also. That technology called UFAS. Okay, so simple. See, we are creating lot of things, right? But there is a huge team. They take care about the what kind of products could be available in the market. So I am not the actual right person who can answer these things. Why this is costly, why this is not costly. How much I could understand, that is the we target to the customers to what kind of customer we can catch. So that is the actual things.
Thank you, sir. Thank you so much.
Thank you.
Any other questions? Okay, Rajiv, I have another thing. As we are shifting from normal MOS devices to some other devices, so till date, so far I can remember, Samsung was last produced 3 nanometer processor and 3 nanometer SSD. So far I can remember. So what is the process they are now using? Process technology, and what are the devices for that particular process technology?
Right now, Vastu, I am telling you frankly, Right now, SOC, I'm actually main guy of SOC, okay. We are creating SOC, that is the 5 nanometer technology only. And Samsung is the first who developed that one, okay. So what you were talking about PDK and everything. And devices, see, in the future, we have to use STT RAM and RAM and other technology as spin talk transistors and so many other things will come definitely. But right now we are still NAND, we are using NAND flash. I'm talking about memory. NAND, NOR, we ignoring the NOR. Normally we have the PDK for the NAND channel. But if you're talking about actual technology, that is CMOS only. Still we are stick to CMOS, but in the future, or one chip we have released, that is depend upon the RRAMs. I'm talking about device. And these activity related to device and everything is taken care in Korea only. So we have very less information related to that.
Okay, thank you. And on behalf of the students, I'd also like to ask another thing. Since, as you can see, you are already in hardware industry, most of our students now getting job in either IT or IT-enabled industries, ITES. So
Yeah.
what should they proceed, or what should the awareness they have that they can go for the industries like hardware industry or VLSI industry or supporting VLSI industry? How should they prepare?
Okay, first thing I will suggest upgrade the syllabus. Okay, still we are teaching the BJT, and what is the, anybody can tell me what is the application, what is the use case of BJT? Why you are teaching the BJT still? Okay, everything move on the CMOS. So, and MOS and BJT both are different direction. That is, if you want to learn MOS, then BJT concept is not required. How in the last 30 years we dumped the vacuum tubes? Why we are not dumping the BJT? First question. Second thing, something you need to introduce in your curriculum. At least the students should know the fundamentals related to that. And fundamental in the sense, second, third thing, the digital should be very good. If you want to come, mostly in VLSI industry, of course, there is analog design is also available, but there are very less opportunity in analog design. Mostly people come into the digital design only. The digital design means your digital should be very good. We expect, even I am in the team of the fresher hiring also. I will not tell you what question I have prepared. They asked me to prepare 10 question paper also. So I'm telling you, the question standard must be gate. I have only prepared for the Samsung 10 question paper, 10 set I have prepared. So mostly the digital level is minimum gate. Okay, so your digital should be very good. Second thing, the 30% weightage of the digital, 30% weightage of the digital. Second thing, your engineering should be very good. Means we ask each part of the we cover all the portion of your engineering. I'm talking about core engineering. If your student is good, he can able to clear the gate exam. He can easily clear the written exam here. Any I'm talking about all the design houses what is available in the India. Either it is the Qualcomm or Samsung or Intel or TI or ARM, AMD, whatever it is, Google, whatever it is. The written level is same. After that, we go through the 2 level of interview. And the level of interview is, they will simply ask, okay, tell me your fundamentals and which subject you are comfortable. But if you are comfortable with digital, that would be good advantages. Second thing, if in your curriculum introduction is not there, try to introduce Verilog HDL. Normally, the company would like, they like it. Okay, fundamentally not at Verilog about Verilog HDL or something. They will appreciate your college. They will like that one. And one more thing, that is my personal suggestion. I don't know, that could be part of your curriculum or not. We have 32 protocols available in the market that start with the AXI and end with this EXL. Okay. So I'm telling you, at your student must aware about what is the master, what is the slave, how this concept is working. I'm talking about bus architectures. Okay. So only one bus architecture is more than enough for them. if they know about AXI is very simple but very useful. If they know or through any training or something, they could understand how AXI work, what is the use case of AXI. Because nowadays I'm telling you the reality, 80 to 90% SOC that develop in the world, that all the interfaces is nothing but AXI only. You can understand what is the use of AXI. Means if I'm talking about a system on chip architecture, so it will be not sufficient. I can say, okay, you have to work on SOC. Always I can say SOC based upon ARM. The 80 to 90% SOC available in the market, that is based upon ARM. Recently, some free and open source people developed the RISC-V. Okay, they try to replace XI, but I don't think that is possible. Okay, so that is my feedback to the organizations.
Okay, thank you so much. Thank you so much for time. Now I hand over the session to Devashish if there is no any other question.
I just want to ask another question.
Okay.
Dr. Kamal. Am I audible?
Yeah. Please go ahead, Dr. Devashish.
It is just not directly related to this program. Just I am asking, as you are in this direction, you are working. 7 or 10 days before, I have seen a news in the Google that Dr. Bill Gates says within 2030, all the smartphone will be obsolete. They will be thrown out. So, but there are not details of what technology is coming. So, can you give insight based on which technology, as you are working in this area?
Maybe
what
that
progress
is
are
more
actually
related,
going?
those are more related to the application only. We are not very much sure because I am the hardcore engineer sense in the chip level, I'm totally chip level. So I'm not sure about on what basis they are saying. But see, our market is not going to be obsolete anyway. Reason is that how many software you are developing, that software runs over the hardware only. Every time what development you can done, either you are Google or whatever. Google is also our client. Okay, now we are maintaining their data centers only. So memory and future of memory is quite very safe. The smartphone, I'm not sure because here the second building is there, that is called the SRIB. I'm working with SSIR. The SRIB is take care about the phones, smartphones and technology related to 4G, 5G and modems. They can better answer. Okay, but I will keep this question in my mind. So I can mail them. So what is going on inside? Sometime we have some internal conferences are there, so we can ask these questions there also.
Okay, thank you. Now, Dr. Basu, have you given vote of thanks? Just I was disconnected few minutes because of network issue. It was completed?
No, it's
Yes,
not yet
Rajiv has
completed.
already completed his session. So,
Okay, you start the vote of thanks.
okay. So first of all, I like to thank Dr. Rajiv Kamal for giving us time in spite of his busy schedule. And I hope this session will be very much helpful for student member of IIC, the other students member of RCC IIT, as well as all faculty members who are present here. Market scenario is changing day by day, and based on that, our technologies are also upgrading, and that is the key thing behind the innovation. And so that's why today's session was dedicated to innovation, and I think Dr. Rajiv Kamal has already given us sufficient input to think on that. So again, a big thank for him. I also like to thank RCC IIT for giving us the opportunity to organize this session. IIC Cell, Institute Innovation Cell, RCC IIT, for organizing this fine activity for today. The other IIC Cell member, the president, the convener, and all coordinators, our student member. I like to thank everyone for their constant support. And after a long time, I can see that we have just started at 3 o'clock and still we are on time that within 4 we are going to end. So that is also a very big thing for us, punctuality. So also like to thank you everyone for considering this. So with this, I like to end the session here. Thank you everyone. Thank you for joining and thank you this mission, today's venture is a successful one. Thank you very much. Thank you all.
Okay, thank you, Professor Basu. I just request everyone to open once the video to take a picture, screenshot. I request all participants to once open the video. Yes. Yes, more participants. I like to, students also, you open your video. Yes. I request more and more students should open their video. Okay. Thank you. Thank you all the participants. Now we are closing the session.
Thank you all.
Okay, Rajiv, thank you very much for giving us time.
Thank you.
Thank you, Dr. Kamal, for your inspiring speech. I hope your experience and speech in this regard, our students will be, and students and faculty member will be highly benefited. In future, we will organize this type of program again. We will invite you. So we will try to organize this program in the physical mode instead of the online mode. In that case, we will invite you. Please join with us in our institute.
Sure. Thank you.
Thank you, everyone.
Hello.
So
Bye.
feedback,
Bye, everyone.
feedback,
Bye.
yeah, bye. Feedback link is given in the chat box. Participant, you give the feedback. Okay. Professor Anup Kwala, your video is, the program is already recorded, I think.
Yes, sir. Shall I stop recording?
Hello.
Hello.
Sir, I end. Sir, I decline the call.
Okay, you can disconnect. If you given
Okay.
feedback, the feedback link, you have given submitted feedback. Have you submitted?
Okay.